sample problems about the lesson Calorimetry, which is all about the heat gain and heat loss. So let us have first the sample problem questions about heat loss. First, 20 grams of copper at 80 degrees Celsius is placed in 60 grams of water at 20 degrees Celsius. The temperature of water increases to 25.5 degrees Celsius. What is the specific heat of the copper? So first, let us look for the given. The given of copper. Its mass of the copper, 20 grams or equivalent to 0.02 kilograms. Initial temperature of copper, 80 degrees Celsius. The final temperature of the copper, 25.5 degrees Celsius. And the missing one is the specific heat of the copper. And for the water, the mass of the water, 60 grams or equivalent to 0.06 kilograms. The initial temperature of the water, which is 20 degrees Celsius. Final temperature of water, 25.5 degrees Celsius. And its specific heat, which is 4,190 joules per kilogram degrees Celsius. So, solution. Let us follow the formula for this topic, which is Q loss equals Q gain. So we have the copper, which belongs to the one who lost, and the water who gained. So mass of the copper, MC delta T. Copper equals MC delta T water. So transpose. Specific heat of copper equals MC delta T of water over M delta T of the copper. So substitute for the given. The mass of the water, 0.6 kilograms times its specific heat, which is 4,190 joules per kilogram degrees Celsius, and its delta T of the water, 25.5 degrees Celsius minus 20 degrees Celsius, over the mass of the copper, 0.02 kilograms times the delta T of the copper, which is 25.5 degrees Celsius minus 80 degrees Celsius. To calculate that, 0.06 times 4,190 times 25.5 minus 20 is equivalent to 1,382.7 joules per kilogram degrees Celsius, over 0.02 times 25.5 minus 80 degrees Celsius is equal to negative 1.09. So 1,382.7 joules per kilogram degrees Celsius over negative 1.09 is equivalent to the specific heat of the copper, which is negative 1,268.53 joules per kilogram degrees Celsius. So, the specific heat of the copper is negative 1,268.53 joules per kilogram degrees Celsius. Second problem about heat loss is 75 grams of an unknown substance at 50 degrees Celsius is put in 200 grams of water at 40 degrees Celsius. When the final temperature of the mixture is 55 degrees Celsius, compute for the specific heat of the unknown substance. So we were looking for the specific heat of the unknown substance. To solve for the problem, Still, let us look for the given first. Given the mass of the unknown substance, or let's have X here to represent the unknown substance. Mx, or the mass of the unknown substance, 75 grams, which is equivalent to 0.075 kilograms. The initial temperature of the unknown substance, 50 degrees Celsius. Its final temperature of unknown substance, 55 degrees Celsius. And the missing one, which is asked in the problem, is the specific heat of the unknown substance. And to the water, the mass of the water equals 200 grams, or equivalent to 0.2 kilograms. Its initial temperature, 40 degrees Celsius. The final temperature of water, 55 degrees Celsius. And the specific heat of the water, 4,190 joules per kilogram degrees Celsius. To solve, let us still follow the formula. Q loss equals Q gain. Since the unknown substance is the one who lose and the water have gain, so let's have MC delta T of the unknown substance is equals to MC delta T of water. Transpose to have the specific heat of the unknown substance. So let us transpose for its formula. Specific heat of unknown substance equals MC delta T of water over M delta T of the unknown substance. Substitute for the given. The mass of the water, 0.2 kilograms. The specific heat, 4,190 joules per kilogram degree Celsius. And the delta T of the water, 55 degrees Celsius minus 40 degrees Celsius over the mass of the unknown substance, 0.075 kilograms times delta T, 55 degrees Celsius minus 50 degrees Celsius. Copy. 0.2 kilograms times 4,190 joules per kilogram degree Celsius. 55 minus 40 is equals to 15 degrees Celsius over 0.075 kilograms times 55 minus 50 equals 5 degrees Celsius. 0.2 times 4,190 times 15 is equals to 12,570 joules per kilogram degree Celsius over 0.075 kilograms times 5 degrees Celsius is equal to 0.375. 12,570 divided by 0.375 is equivalent to 33,520. Cancel both are the same units, which are the kilograms and the degree Celsius. So joules per kilogram degree Celsius is the unit left. So we have 33,520 joules per kilogram degree Celsius, which is asked in the problem. The specific heat of the unknown substance is equal to 33,520 joules per kilogram degree Celsius. Last sample problem for the heat loss. The third one. A silver necklace at 30 degrees Celsius is dropped into 20 grams of an ethyl alcohol at 40 degrees Celsius. The final temperature of ethyl alcohol is 66 degrees Celsius. Given the specific heat of the silver at 230 joules per kilogram degree Celsius and 2,430 joules per kilogram degree Celsius for the ethyl alcohol, what is the mass of the silver? So again, let us look for the given first. The given. Initial temperature of the silver, 30 degrees Celsius. Final temperature of the silver, 66 degrees Celsius. Its specific heat of the silver, 230 joules per kilogram degrees Celsius. And what the problem asks for is the mass of the silver. So let's leave it blank there. Another, the initial temperature of the ethyl alcohol, 40%. The final temperature of the ethyl alcohol, 66 degrees Celsius, And the specific heat of ethyl alcohol, 2,430 joules per kilogram degrees Celsius. And its mass of the ethyl alcohol is 20 grams or equivalent to 0.020 kilograms. So for the solution, Q loss equals Q gain. MC delta T of silver is equal to MC delta T of ethyl alcohol. Transpose to have the mass of the silver. Mass of the silver equals MC delta T of ethyl alcohol over C delta T of the silver. Substitute the given mass of the ethyl alcohol, 0.020 kilograms times its specific heat, 2 times 2,430 joules per kilogram degrees Celsius, and its delta T, 66 degrees Celsius minus 40 degrees Celsius, over the specific heat of the silver, which is 230 joules per kilogram degrees Celsius, and times its delta T, 66 degrees Celsius minus 30 degrees Celsius. So solve. Copy 0.020 kilograms times 2,430 joules per kilogram degrees Celsius. 66 minus 40 degrees Celsius is equal to 26 degrees Celsius over 230 joules per kilogram degrees Celsius. 66 minus 30 degrees Celsius is 36 degrees Celsius. 0.020 kilograms times 2,430 joules per kilogram degrees Celsius times 26 is equal to 1,263.6 kilograms over 230 times 36 is 8,280. 1,263.6 kilograms divided by 8,280 is equal to 0.15 kilograms. So 0.15 kilograms is the mass of the silver. Another sample problem, which is about heat gain. First problem. A 10 kilograms of a known substance at 40 degrees Celsius is dropped in a water at 50 degrees Celsius. When the mixture has its final temperature of 52 degrees Celsius, with a given specific heat of the unknown substance, which is 120 joules per kilogram degrees Celsius, what is the mass of the water? So let us have or look for the given first. Given the mass of the unknown substance, 10 kilograms, initial temperature of the unknown substance, 40 degrees Celsius, final temperature of the unknown substance, 52 degrees Celsius, and its specific heat of the unknown substance is 120 joules per kilogram degrees Celsius. The mass of the water, which is the missing or what the problem asks for. So let us leave it blank there. The initial temperature of the water, 50 degrees Celsius. final temperature 52 degrees Celsius and the specific heat of water 4,190 joules per kilogram degrees Celsius. So solution, Q loss equals Q gain. Since the one who lose is the unknown substance and the one who gained is the water, so we have MC delta T of unknown substance is equal to MC delta T of the water. MC delta T of the unknown substance over C delta T of water equals the mass of the water. Substitute the given. The mass of the unknown substance 10 kilograms times the specific heat of the unknown substance 120 joules per kilogram degrees Celsius, and its delta T 52 degrees Celsius minus 40 degrees Celsius over the specific heat of the water 4,190 joules per kilogram degrees Celsius times its delta T 52 degrees Celsius minus 50 degrees Celsius equals to the mass of the water. Copy 10 kilograms times 120 joules per kilogram degrees Celsius. 52 minus 40 equals 12 degrees Celsius over 4,190 joules per kilogram degrees Celsius. 52 minus 50 equals 2 degrees Celsius. So 10 times 120 times 12 is equals to 14,400 kilograms over 4,190 times 2 equals 8,380. 14,400 divided by 8,380 is equal to 1.72 kilograms. 1.72 kilograms would be the mass of the water. Second problem. A steel that weighs 50 grams at 35 degrees Celsius is being placed in 55 grams of water at 30 degrees Celsius. The water temperature increases to 40 degrees Celsius. What would be the specific heat of water given that the specific heat of the steel is 460 joules per kilogram degrees Celsius? So now we were looking for the specific heat of the water. Look for the given first. Given the mass of the steel 50 grams or equivalent to 0.05 kilograms. The specific heat of the water or the specific heat of the steel 460 joules per kilogram degrees Celsius. Its initial temperature 35 degrees Celsius and the final temperature of the steel is 40 degrees Celsius. To the other side, the mass of the water is equal to 0.055 kilograms. Initial temperature of the water 30 degrees Celsius. The final temperature of the water is 40 degrees Celsius, and the missing one is the specific heat of the water. So, to answer for that, let us use the formula. Solution for the problem. Q loss equals Q gain. MC delta T of the steel is equal to MC delta T of the water. Transpose MC delta T of the steel over the M delta T of the water is equal to the specific heat of the water. Substitute the given. The mass of the steel 0.05 kilograms times 460 joule per kilogram degree Celsius, which is the specific heat of the steel, and its delta T 40 degrees Celsius minus 35 degrees Celsius over the mass of the water 0.055 kilograms times its delta T 40 degrees Celsius minus 30 degrees Celsius is equal to the specific heat of the water. So copy 0.05 kilograms times 460 joules per kilogram degree Celsius. 40 degrees Celsius minus 35 degrees Celsius is 5 degrees Celsius over 0.055 kilograms times 40 minus 30 degrees Celsius equals 10 degrees Celsius. So 0.05 times 460 times 5 is equal to 150 joules per kilogram degree Celsius over 0.055 kilograms times 10 equals 0.55. So cancel the same unit, which is the kilogram and the degree Celsius. So we have joules per kilogram degree Celsius left. So 115 joules per kilogram degree Celsius divided by 0.55 is equal to 209.09 joules per kilogram degree Celsius. So the specific heat of the water is 209.09 joules per kilogram degree Celsius. Third one, which is the last sample problem for the heat gauge. At 45 degrees Celsius of 2 kilograms of gold with its specific heat of 130 joules per kilogram degree Celsius is being dropped in a 50 grams of water at 30 degrees Celsius. As the temperature of the water increases to 50 degrees Celsius, what would be the specific heat of the water? So now we are looking for the specific heat of the water. So let us look for the given. The mass of the gold is 2 kilograms. The specific heat of the gold, which is 130 joules per kilogram degree Celsius. Its initial temperature 45 degrees Celsius, and the final temperature of the gold is 50 degrees Celsius. Go to the other side. The mass of the water equals 200 grams or 0.2 kilograms. Its initial temperature 30 degrees Celsius, and the final temperature of the water is 50 degrees Celsius. And we have the missing one is the specific heat of the water. So solution. Q lose equals Q gain. Since gold is the one who loses and water gains, so we have MC delta T of gold is equal to MC delta T of the water. MC delta T of gold over M delta T of water is equal to the specific heat of water. Substitute for the given. The mass of the gold 2 kilograms times its specific heat 130 joules per kilogram degree Celsius times delta T 50 degrees Celsius minus 45 degrees Celsius over the mass of the water, which is 0.2 kilograms times delta T 50 degrees Celsius minus 30 degrees Celsius is equal to the specific heat of the water. Copy 2 kilograms times 130 joules per kilogram degree Celsius. 50 minus 45 degrees Celsius is 5 degrees Celsius. Over 0.2 kilograms times 50 minus 30 equal to 20 degrees Celsius. So 2 times 130 times 5 degrees Celsius is equal to 1,300 joules per kilogram degree Celsius over 0.2 kilograms times 20 degrees Celsius is equal to 4. So 1,300 joules per kilogram degree Celsius divided by 4 is equal to 325 joules per kilogram degree Celsius, which is the specific heat of the water. So that was my sample problems, and I hope that you have learned something from it. Thank you for watching, everyone.